this lesson, we're going to be learning about a different kind of way that we can categorize reactions. So this is actually kind of a subset of double replacement reactions known as precipitation reactions. So a precipitation reaction is when a solid product is created by a double replacement reaction. And the solid product itself is what we call the precipitate. Precipitate is commonly abbreviated PPT, so you might see me use that. And when a precipitation reaction happens, when a precipitate forms, it causes the solution to become cloudy or opaque. So we know that double replacement reactions usually occur between two solutions of different substances. Because those substances are dissolved, the solutions are clear, they are translucent. They may be colored, but they are see-through. When a precipitation reaction occurs, when you mix two clear solutions together, all of a sudden it becomes cloudy or opaque, is how you know that a precipitation reaction has happened. And if you let it settle, if you let it sit, that solid will eventually settle out to the bottom of your container, and you'll be left with a clear solution and the settled solid on the bottom, which is why we call it precipitation, because it is like falling down to the bottom if you let it settle out for a little bit. So the reason why precipitation reactions occur sometimes is when one of the products of your double replacement is not soluble in water. So there are some ways that we can predict whether or not a substance is going to be soluble in water. We're going to learn a few kind of very basic guidelines in this video. But the general gist is that some combinations of cations and anions are soluble in water, while others are not. So the thing that is soluble, or any things that are soluble, will stay dissolved. So when you're doing a double replacement reaction, you are generally starting out with soluble substances dissolved in solution. If your products are also soluble, everything stays dissolved in your solution and your solution stays clear. If something is insoluble, that means it can't stay dissolved. So it's going to turn into a solid, which we call the precipitate. So there is a more extensive list of sort of rules to help you predict what things are or are not soluble that if you take Chem 2, you will see there. For now, there are a few ions to be aware of that are always soluble in water no matter what they are paired with. And those are the ones I am interested in you knowing right now. So there are 4 of them. They are sodium ions, which is Na+, nitrate ions, which is the NO3- polyatomic, the acetate ion, which is another polyatomic, C2H3O2-, and potassium. So there are some other ones in the always soluble category, but these are some of the most common ones that you will see, and therefore I think they're the most important to recognize right now. If it helps, you remember the acronym SNAP for sodium nitrate, acetate, and potassium are the ones to recognize that no matter what else this is paired with, that compound is always going to be soluble. So it doesn't matter what you put it with. If I give you the formula sodium oxide, Na2O, that is soluble because sodium is part of it. So it doesn't matter what anion I attach to that, sodium whatever is always going to be soluble. Same goes for the other ones. Doesn't matter if I give you magnesium nitrate or silver nitrate. Any cation paired with nitrate is always going to be soluble, is what I mean by that. So anytime you see one of these ions as part of an ionic compound, that ionic compound is going to be soluble. So for right now, that's all I'm giving you in terms of solubility guidelines to be familiar with. So I will still need to tell you that like this reaction does form a precipitate in some way, shape, or form. But from that, you will generally be able to identify which product is going to be the precipitate, because if a product involves one of these ions, it's not the precipitate. These guys are going to be soluble. They are never going to be part of a precipitate. So that can honestly help us get a long way in terms of predicting what the precipitate of a reaction is going to be. So let us take a look at a reaction example. So if we have the following reaction, and we are told that it produces a precipitate. Again, for now, I need to tell you that. Take Chem 2, and you'll be able to predict it on your own. We want to complete and balance the reaction and identify the precipitate. So precipitation reactions are kind of a subset of double replacement. We can see that we have two ionic compounds reacting here, so we recognize that of the tools in our toolbox, double replacement is the one that makes the most sense anyways. So we are going to have our ion swapping partners. That means that the sodium is going to end up paired with the chloride, and the barium is going to end up paired with the sulfate. We need to remember that we want to make sure we are writing formulas that make sense, that we are writing formulas where the charge on all of our ions adds up to 0. So we want to think about what the charges on these things are. So we know that barium is in group 2. That likes to form a +2 charge. Chlorine is a halogen. Those like -1, which is why there are 2 chloride to every barium in that formula. Sulfate is one of our polyatomic ions, so we can look up its charge as -2. And we know that sodium is one of the alkali metals, which likes a charge of +1. So those charges stay the same on the product side. So when we go to look at our new pairings, we're going to have sodium paired up with chloride. Sodium is a +1 ion. Chlorine is a -1 ion. So that is good to go. We do not need any subscripts, and remember that we always want our subscripts in lowest terms. So a really common mistake I see is people wanting to just bring the same subscripts over, and unfortunately it doesn't work that way. So we want to write our formulas first and worry about balancing it afterwards. So sodium chloride is good to go as is, and then that is the wrong color. Barium is going to end up paired with sulfate, and we know barium is +2, sulfate is -2, so that one is also good to go. We don't need to make any adjustments to our subscripts to have our charges add to 0. So the last thing we need to do is balance our reaction. Currently, we have 1 barium and 1 sulfate on the left, 1 barium and 1 sulfate on the right, so that is fine. We have 2 sodium and 2 chloride on the left, but only 1 sodium and 1 chloride on the right. So the last thing we need to do to balance this reaction is to put a 2 in front of that sodium chloride. And then we're also asked to identify the precipitate. So we want to look at what our products are and what we know about our solubility guidelines. And one thing that we know is that sodium ions are always soluble. No matter what compound they are in, if it is an ionic compound containing sodium, it is going to be soluble. So that means that this guy is going to stay in the aqueous phase. We were told that this reaction produces a precipitate. By process of elimination, if our precipitate is not the sodium chloride, it must be the barium sulfate. So the barium sulfate must be insoluble, meaning it is going to form a solid here. So we can label those states of matter. And our precipitate is that barium sulfate, is that BaSO4.